We're looking at the graph of a hyperbola. Hyperbola are in the form, as we can see here, y equals 1 on x. Now, this shape here is the classic hyperbola. More correctly, these are called rectangular hyperbolas. Now, the rule is 1 on x. If we put x values into the rule, put 1 in, 1 on 1 is 1. Put 2 in, becomes 1 on 2, so y is a half. Put 3 in, y will equal 1 on 3, 0.33 it says here, actually exactly a third. Put 4 in, it's 1 on 4, a quarter, or 0.25. Now if I put a number less than 1 in, so if I put a half in here, so it reads 1 divided by a half. 1 divided by a half is 2. There's 2 halves in 1. And if I put 1/3 in, 1 over 1/3 is equal to 3. And 1 over 1/4 is equal to 4. Putting a negative value in, so if I put -1 for x in the rule, it becomes 1 divided by -1, y equals -1. If I put -2 in, 1 divided by -2 is -1/2. So these values here, the y values are the negative of these values here. Now what's going to happen if we keep going out and putting bigger and bigger x values in? You can see the graph looks like it's getting closer and closer to this x-axis. In fact, if I put 1,000,000 in here, the answer would be 1 on 1,000,000, which is a pretty small number, but it's not 0. In fact, there's no x value I can put into this to make 0. If I put 0 for x-axis, we get 1 divided by 0, and that has no meaning in mathematics. Over here it actually says infinity, but what we find is as we get closer and closer to 0, the graph starts climbing very quickly. So if I get a really, really small number, like if I put 1,000,000th into x here, y would equal 1,000,000, which is a long way up there. But it's never going to equal 0 though. So there's no value I can put x equals 0 or y equals 0 into this graph to make x 0 or y 0. So to indicate this on the graph, we put these dotted lines on, which are called asymptotes. These asymptotes indicate a line where the graph approaches but never ever actually reaches that value. So this vertical line here has the equation x equals 0. So the graph approaches x equals 0 when we come from the positive side, but never ever meets it. And if we come in from the negative direction, we start going down to negative infinity down this way, and never approaches that. It approaches that line but never touches it. And likewise, if we go out to the extremes, x becomes very, very negative, or x becomes very, very, very positive, the graph's going to approach 0 but never ever equal that value of 0. Okay, that's the first graph you need to put in your notes. You might need to pause the video there and add that. The next graph we're going to look at is now changing the value of a to 2. So a is actually the value above the x. So this is now becomes 2 on x. What's the effect on our graph? Well, each existing point on the original graph, which is our dotted red line, has been dilated from the x-axis by a factor of 2. So you see the y value in the original point here, 1, 1, is now 1, 2. So if I put 1 into the rule here, 2 divided by 1 equals 2. We can see that over here. If I put 2 into the rule, now it's going to be 2 divided by 2 equals 1. So that y value is twice as high. You'll see this one, the y value originally was 1/3, now it's 2/3. Here the y value was originally a quarter, now it's a half. This y value here originally was 2, now you can see it's gone up to 4. And likewise in the negative section. What happens when we change a to 3? Once again we can see it stretches the graph further from the x-axis, now by a factor of 3. It's 3 times as high. Still got these lines where the graph never is going to touch, but still will certainly approach these lines, but will never ever equal. And if I keep continuing making A bigger, we can see the stretching goes on and on. Alright, they're the ones you need to draw initially, and you also need to draw this graph, which is 0.5, where A is a half. Now that can be written as 0.5 on x, or could also be written as 1 over 2x, because 0.5 is 1 half, 1 over 2. And what does this effect have? Well, let's go back to our standard 0.11 here. Multiplied by a factor of a half now becomes 0.1, 0.5. 0.2, 0.5 now becomes 2.25, half as big. And you can see all those points there. If you look in the negative area, the same thing happens. Okay, so that's, you need to fill in the comment box on what A does, and actually what happens when A is positive, and complete the questions underneath. The next thing we'll do is look at when A is negative. Here's the first one. I'll make A negative, so it makes this negative 1 on x. The negative can be written out the front or with the 1. So it's negative 1 on x. And what does this do to our graph? All these values here in the original graph, the red dotted line, are flipped over the x-axis, make the black graph. So 0.11 is now, x is still 1, but y is now negative 1. Here, when x was 2, y was 0.5, but when flipped over, it comes to negative 5. Look at the point 0.52, that becomes 0.5, negative 2. The negative values, x, which produce the dotted red line for the graph 1 on x, when flipped, we can see the y value now becomes positive. So negative 1 becomes positive 1, negative 2 becomes positive 2 for the same x value. Because we'd be dividing negative 1 by a negative number makes a positive answer. What happens if we make a negative 2? We get the same effect, it's still reflected over the x-axis, but now the stretching from the x-axis is twice as far. So the point negative 1, it becomes negative 1, positive 2. The point 11 becomes the point 1, negative 2. The table values there for the exact values, you can't read them off the graph. So the next one you have to plot is where A is 3. So the rule now is negative 3 on x, and still got the reflection, because that's what the negative does, it reflects the graph. The 3 stretches it by a factor of 3 after it's been reflected. And if we went further out, so the graph just keeps getting stretched, still reflected. And if we have a look at a case where A is a half, negative a half, we can see that the graph is still reflected, but the stretching is half as much. This point up here was a quarter 4, now it's a quarter negative 2. The 0.11 is now the 0.1 negative 0.5. Over here, the point negative 1 is the point negative 1 positive 0.5. Need to now complete the questions on the section Hyperbolas and do the questions. Thank you.